Hello guys, welcome back. So in this video we are going to understand this question. This question is very important because this question is belongs to the graph, and so we'll discuss more about this question, right? But I will also give you the hint of the theory that we are going to use in this program, right? So first of all, just pause this video and read this so that you will get more ideas of this. Okay, so let's understand. So the question is saying that the earliest moment when everyone became friends, right? So there are n people in the social group that is level from 0 to n minus 1, and you are given a logs at I, where timestamp we have given xi and yi. So it indicates xi and yi will be the friends at the same timestamp. What does it mean? Let's suppose the first line of the statement, what is saying? So it is saying that let's suppose we have n people leveled from 0 to n minus 1. So if n is equal to, let's suppose 6, right? So there can be a possibility that the social group will look like this: 0 1 2 3 4 5, like this. Okay, so if we'll talk about the nodes, we can say these are the people, right, that in the group. Okay, so we can connect like this, right? So these two, so initially 1 0 and 1 become friend, 1 and 2 friend, 0 3 friend, like that it will become. Okay, apart from this, we can say this is also become friend like this, or you can leave it for now. Okay, means all of them are connected with each other, right? So it is saying that the xi and yi will be the friend at the timestamp this. So there will be time given, right? At that time, these xi and yi, let's suppose x and y, the two persons become the friend. That time is called timestamp. Okay, so it is given the timestamp. The time is given the timestamp when the friend becomes, right? So like that, this statement is saying, right? Now it is saying that okay, give me 1 second to clean up. Okay, now understand what it is saying, that now the next line is saying that friendship is symmetric, right? Symmetric is similar to both sides, right? That means if A is a friend with B, then B is a friend with A. Means this is not the one-sided. This should be the symmetric, both-sided. Means if A is the friend of B, B should be the friend of A. Means like that we can say both side the relationship should be same from the x and y. Also it is saying also person A is acquainted with a person B. What does it mean? So it is saying acquainted means what is happening, let's suppose you are familiar with someone, right? So that words you can use as acquainted, right? Means you are familiar with B, right? So person A is familiar with person B, right? If A is friend with B, right? So A should be friend of someone acquainted with B, right? Means he should be aware of with the other friend, he should be the familiar of that, right? So this is the call symmetry, right? This is the condition we have given here. Now the question is saying return the earliest time for which every person became acquainted with every other person. You got my point? So it is saying that we have to return the time where every person became the friends of other person, right? That time, if the person is no such earliest time, right, we return -1, right? So you pause this video right here and read this statement again, so you will understand clearly. So the question is saying that we have to return the earliest time for which every person became familiar with every other person, right? If there is no such earliest time, we will return -1, right? So let's suppose we have given an example here, right? So this example at logs, we have given a timestamp, we have given 0 1 given, another like 0 is a person, 1 is another person, right? X and y, and this is timestamp. Like that we have given many persons relationship here and timestamp here. So total person we have given is n is 6, right? And we have to find the timestamp. So you can see that it is saying that the first event occurs at timestamp here, where 0 and 1 become friend, and we have the following groups: 0 1 2 3 4 5. So initially what it is happening, so all the person, let's suppose 0 to 6 we have, right? 0 1 2 3 4 and 5, right? So these are the initial persons are there. So we will consider as a individual person. Why? Further we'll talk about in the video, right? In the session you can say. So initially these are independent group we will consider as, because they have not joined any group, right? They are independent. Initially they are independent. So total how many groups are there? Because all persons are not connected with each other, all are not friendship, right? In the relationship is not friendship. In that case they are independent. Okay, that is why it is we can say the friendship group is independent. Once at this timestamp came, right, here 0 and 1 became friend. That is why here we have taken 0 and 1 in one group and the rest are in a other group, right? Now if we'll talk about the group, how many groups are there? So these two are in one group and rest of are the independent group. So total how many group is there? 1 2 3 4 5, right? 5 groups are there. Initially it was 6 group, right? Like that, when we will connect at a different time stamp, what will happen? It will go to it will create a our own, it will merge the, you can say, group, right? It will merge the group, right? So it is merging. So at every time, every time stamp, what is happening? One group is vanished because it is merging two groups. And after when we come to the last one, the sixth event, right, when happened, then what happened? All became friends, means all are merged into one, because they are separately becoming one by one, right? So what will happen? Lastly we have got two groups, right? So nothing will happen. And in the fifth I forget to say that in the fifth one 2 and 4 are already friends, means we will not do anything, because you can see 2 and 4 is in the same group right here, so we will not do anything. But when it is in independent group, then what we will do? Like at the sixth event, right, we will connect 0 and 3 and it will become of all in a single group. I think you understand my intuition what I am trying to say, that right? So the problem, so this problem deals with relationship, or you can say membership of entities, right? So when the problem is given like this, you can say relationship, membership, right, like that. So this type of questions is a perfect example of UnionFind data structure. If you are aware with this UnionFind data structure, it's fine, continue it. Otherwise pause this video, understand what is UnionFind data structure. Otherwise, if you have a little idea, you can continue, because I will discuss more in this video. Okay, so since UnionFind data structure, that we also say disjoint sets, right? So is a data structure that keeps track of connectivity among interconnected individuals, groups, you can say, right, as we have seen here, right? So since with UnionFind one can quickly determine which group a specific individual belongs to. You got my point? Means, as you can see, we have given different timestamp, right? At different timestamp we don't know which one will go to belongs to which group, right? So as you can see here, right, with the UnionFind we can quickly determine which group will a specific individual belongs to, right? So currently as we go to the fifth timestamp, right, you can say 2 and 4. So if we used UnionFind, right, so we can directly find 2 and 3 belongs to the same group. So UnionFind, that is why I'm thinking to use the UnionFind data structure. Also in addition to we can say one can quickly merge two individuals together along with two groups that they belongs to, right? Let's suppose as name suggested, right, UnionFind. So a typical union of find data structure usually provide two interface interface method, you can say, right? So there is one find A. So we have UnionFind, right? we have UnionFind. So UnionFind data structure. So UnionFind data structure provides typically two interfaces, right? One, if you are aware with find A, another is union X and Y, or A and B you can take, right? So this function, find A function, what it does, this function returns the group that individual A, let's suppose here, belongs to that group, right? It will give the group where it belongs, right? And if we are providing two A, let's suppose A and B, right, union of A and B, in that case what happened? So this function merge the two groups that the individual A and B belongs to respectively, right? So if the group are not the same group, right, if the groups or you can say these A and B, if they are belongs to the same group, it will not do anything, but if it is in the different group, it will merge it. Got my point? So let's suppose in the previous one, at when we were here, right, line number 0 and 3, let's suppose 0 and 3 all belongs to 0 belongs to this group and this belongs to this group, right? So then we will do merge, right? Because these are in different group, then we will merge. But at the fifth event, 2 and 4 in the same group, then we will not do anything, right? So as you know, so let's go to the blackboard and then we'll try to understand it. Okay. How many groups are there? So totally how many groups were? Let's suppose the group count we have given is nothing but n. So initially if n we have given, right, so total how many elements are there initially? Let's suppose 6 elements we have given, right? So how many group will be there? Simply total number of groups are same, right? Individual we have not merged anyone, both are not friends, right? So it will be equal, right? So we can say why we are taking this, we want to track what each individual, right? You can see the we check the spelling, okay, separate, right? We will track each individual as separate group, you can say like this, right? Okay. Now if we will talk about the UnionFind, right? We will use the UnionFind data structure because this code will, this type of problem belongs to that where the connectivity comes, relationship comes, right? We will use the UnionFind. Okay, so I will use UnionFind, and I'll say UF is object of this class new UnionFind. I will create the method UnionFind object, and I will pass the number of element. So in that case what we have to do, we have to create this class, right? Where we will create the class, let's suppose I'll create outside this one, right? Class UnionFind, and like this we will provide. Okay, then public UnionFind, and then int n, and then like this. So now what is n here? N is nothing but the size of the data structure, right? So I'll take size here, right? I will take as a size here, right? You got my point? First of all, what we are talking about, like what is union data structure? So union data structure is that we will pass the size, right? So that we can create the object of this, right? So in the union data structure there should be two attributes at least. The first is we should write in private, and then we should give the array form, and this should be group. How many groups are there, right? So groups, all the groups should be in the array, right? Then we can take int private int, and this is nothing but the rank, right? Group and rank we will take, and both of these we will initialize here. How we will do? This dot group equal to, we will provide new int, and we'll provide the size, right? This is the size. So how many groups are there, how many elements are there, then that number of groups will be generated. You got my point? Then we'll create this dot rank, right? And then we'll create new int and we'll give size. Like this we will provide. Okay, so how many groups are there? Number of n, what, and we have given number of peoples we have given, so total number of peoples will pass here, right? You got my point? Like that we will do. Okay, let me reload this one. I don't know, little slow I am seeing this one, so I thought to reload this. Let me increase the font here. Yeah, okay, much better. Okay, so this is done. So we have initialized the group and then we have initialized the rank. Now think as a problem solver, how we are going to understand. See, we will start int person 1, person 0, let's suppose, because level from 0 to n minus 1, right? So I'll go with the int person 0 to person should be less than size n minus 1, right? Correct. And then one by one will increase the person plus plus, right? Means we will iterate all the person one by one. Now what we will do, we will put over the group, right? So we will initialize the group like we have already initialized. Now we'll assign the value. So the person at this group is nothing but this person, correct? Like this, right? Now what is the rank? This dot rank of this person equal to person. Okay, so we have initialized the group and rank, and also each element at the you can say array, each index at the array we have initialized the value, right? We have assigned the value. Okay, now this part is done. Now think that like if we want to return the ID of the group that the person belongs to, right? Means the group ID we want to return from where the person belongs to. So let's suppose I'll write here, we will return the ID of group, right, that the person belongs to, right? How we will do that? We will write public int find. You know, find is a method, or you can say interface in the user UnionFind data structure, from where we will pass the person. Let's suppose int I'll pass the person, so we will get from which group this person belongs to, right? So for that we'll check the person, we'll check in the group this dot group, right? We have group, right? This dot group at the index person is not equal to, we'll say person. First of all we'll do, sorry, I have capitalized my keyword, person. Okay, if we have not equal to this, in that case we will do this dot group at person, right, equal to this dot find, then we'll pass this dot group at person who is at this index that we will assign. Otherwise we will return, otherwise we can return we will return this dot group at person, like this. You can see, right? So this function, what it will do, so union find data structure contains a method find in which we will pass the person and it will return from where this person belongs to that group or not, right? So it will return the ID of the group where the person belongs, right? Similarly, we will create you can say a function, right? A union function, because union data structure contains two methods, right? The union and the find method, right? So why we will create this one? So if it is necessary to merge the two groups, right? That we can say X and Y belongs to. So we will merge X and Y, right, if they belongs to the particular two group, right? In that case, what we will do, we will return true. If both are belongs to the same group, will return, right? Otherwise will merge. If the groups are merged, we will return true if the groups are merged, right? Otherwise false. So I will write the function name public, we should take as a boolean, and then we'll say union, right? So I'll take a union function, will pass two let's suppose A and B, both are person A, person B, we can say, and then you can write person A, person B also, okay? And then we'll say int group A is this dot find, let's suppose. So we will get the group from where, from which group it belongs to, right? Similarly, I'll write for B, right? So we can find the group of person B. So we can find now. So if we have merged, then we have to find boolean in the boolean sense, right? So is merged will take a function is merged, is false will take, let's suppose, and we'll say if it is merged, right, means both should be same, right? Let's suppose if the two person or two people share the same group, then what we will do? In that case, we'll make a condition. If group A belongs to group B, if it belongs to group B, we will return is merged, right? Means this is true, then we will return it, right? If it is belongs to the same, it is equal to same, right, is equal to, then we'll say we will return, because we are not going to merge, right? Means we will return false, okay? Otherwise what we should do? Merge the two groups, because these two groups are different, merge it. Then in that case we'll say is merge is now become true, right? Because once these two are merged, we'll say is merge is true. Now think, now in which group it will go, that we have to see. Let's suppose we have merged the lower rank group into the higher rank group. How we will do that? If the ranks are different, then how we will do that? In that case, we'll say if this dot rank belongs to the group A, means group A rank is greater than this dot group at rank at group B. If it is bigger than the rank is better than or bigger than or greater than group B, in that case what we will do, we will assign this dot group of group B equal to what, group A. Then we'll assign group A, group B will go to group A, like that we will do. Okay, else condition will do, else if this dot rank goes this dot rank of group, you can say A, is less than this dot rank at group B, let's suppose like this. Okay, in that sense what we will do, we will say this dot group at group A equal to group B. Then we will assign like this. Else what we will do, we'll say this dot group of group A equal to group B, right? Then we'll say this dot rank of group B equal to
Thank you guys, thank you for watching this video,
1.
and if you really like this video, please subscribe
And
this channel.
then we'll say return is merge, we'll return the is merge. Okay, you understand the point? The first of all we'll find the group of each person, then we'll check if both are the same, we will not merge, otherwise we will merge and we'll mark it as a merged. And to merge that we will check the ranks. If the rank of group A is greater than group B, we will assign group B into group A. If the rank of group A is less than group B, the group of A we will assign into group B, and similarly otherwise if this is not the case, what we will do, we'll increment, we will create we will assign the group of A into B, and also we'll increase the rank, +1 will do. Okay, and then we'll return is merge is true, right? So this is the thing that we have to do in the UnionFind data structure. I think you will be aware of this. If not, I think this is the good understanding for you to understand the UnionFind data structure. Still, if you have any doubt, please ping me in the comment box. I'll really help you there. Otherwise, if you want one-to-one classes or in my group classes you want to join, please ping me in the comment box. I'm really free right now, so you can join. Okay, let's continue here. Now if you'll talk about we how many group initially we have, the number of persons that we have. So individual group are 6 initially, 6 we have given, 6 is there. Okay, number of groups is equal to n. Okay, so to sort the you can say the logs, right, timestamp in chronological order, right? What we should do, we will sort it, right? So I think you will be aware of this, that we can write arrays, you are aware of that, arrays dot short, we'll call this, and there is a comparator is there, you can see here, right? That we will talk. So for that we'll pass two things, right? To sort it, I will pass the logs and another will be the comparator. So I'll create a new comparator because we don't have the comparator, so I'll use a new comparator, new comparator, like this I will provide. And for that we have to override it, right? Override override, what we will override? So there is only one method, you know, this is a function interface, right? And the function interface of comparator having only one function abstract method, that is compare method. So I'll use public int. You can use lambda expression also to write the code, but I'll write very simple, so everyone will be fine. So there is a compare method is there, so we will override this and we'll pass two things, a and b. So a is, what is the a? A is the log1, and similarly I'll provide the array 2, that is nothing but log2. So 2 log will provide, and we'll compare it. Okay, so to compare this, what is that log0? Log0 we have the timestamp, log1 we have friend1 and person1, and log2 we have person2, right? So we'll take integer, right, and I will say tsp1 timestamp of person1 equal to new integer, and this is what we will pass here, nothing but logs at log1, we can say, right, log1 at 0, right? Like this we will write. Okay, similarly I'll copy this line of code and I should write for at log2 we will get esp2, right? So those two things we will get, right? Timestamp of person1 and person2 we will get. Now we will return this, because we have to return the value tsp1 dot compared to tsp2, like this. Okay, so this is the way we used to write the code. And then there is one error, because we don't require these things, right? We can directly write the code like this, or other what we can do, keep it here and we can write we are using array, so we'll pass this like this one. Okay, so now your timestamp are sorted in chronological order, right? So that we can compare based on the timestamp, right? At each timestamp we'll check if it belongs to the same group or not. If it is in the same group, right, we will not merge. If it is in a different group, we will merge. You got my point? Okay, now once your data structure is ready, because it should be ready, we have already initialized this with the, we are passing the n, so UF is ready, UnionFind data is ready. Now we will iterate over all the logs. So one log at a time will get from the logs, right? So we'll get from the logs, we'll do this one and we'll get the array of logs. Okay, so we know that at 0 we have the timestamp we have at we can say log at 0, right? Log at 0 will timestamp this one. Then we have what we can say friend A we have at log at 1, right? Similarly we have friend B, this is at log 2. Got my point? We have timestamp, friend A, friend B, right? All these things we have. Now what we should do, we'll write if UF dot union, it will pass A and B. A is what? Friend A, right? Friend A, and here we'll pass friend friend B. Okay, like this. Okay, then we should check the functionality, right? UF, yeah, we will give the body, and then we'll write group count, we will decrement by 1, and this is nothing but decrementing, because we are merging, right? So if the we are going if the timestamp be given at this timestamp for particular value, right? Let's suppose timestamp, first timestamp, second timestamp, 3, 4, right, like that. So at each timestamp we have two friends A and B. Now we will merge these two friends, right? Why we are merging? Because if we will merge this, then only it will have the friendship relationship. And then if we are merging this one, so we have to reduce the group count, right, each time. Because if 0 and 1 is connected now, so now 0 1 have 1 separate groups, now they belongs to one single group, right? So we'll do with -1 decrement. Now now we have to check once this is done, right? Once this is done, we will check one more thing. If the moment when all the individuals are connected to each other, let's suppose, means now the group count is equal to 1, means we have iterated all the timestamp with all the friends, we have merged it. Once it is merged, there will be only one group count, because now everyone is merged, right? Once every is merged, there is only one group, that is called our friendship group, right? And this is the way we will return the timestamp, where we have to return the timestamp where all became friends, right? Everyone knows each other. You got my point? If this is not the case, if they are not becoming, then we'll return -1 here, like this we will say. Got my point? If the group count is equal to 1, it's fine, we'll do this. Otherwise we'll return -1, right? I think not in this one, we should take it out, because otherwise it will be error. Yeah, I hope. Let me zoom out a little bit. Yeah, correct. Because see, if you'll pass into this method in the for loop, in the first iteration we'll do, that time it will get cancelled, because it will not continue for the next timestamp, right? So like this we have to iterate one by one, and then we have to do. I think you understand, right? So let me run this code. Yeah, accepted. So what we have to do, what we are doing actually, we have given the group count, right? We have given the group count. Now the group count is initially number of persons we have, so individual group count is same as number of people. Now what we have to do, we have to sort this timestamp, you can say, in chronicle order, so that we can iterate one by one timestamp, right? So to iterate this, right, what we have to do, we have to create the UnionFind data structure where we can do union, right? And in union means we will merge it, and then we'll get our you can say timestamp, right? We can get after the merge we will have our group count incremented or decremented, not incremented but decremented each time, right? And once it is decremented and equal to 1, means there is only one relationship, friendship relationship, and only one group is there, right? And I think you are aware with the UnionFind data structure, means in the UnionFind data structure there should be two things, the group and the rank, right? And to initialize this UnionFind data structure, we have to provide the number of people, or you can say group that is required. So number of group we will initialize, their rank we will initialize, and we will iterate for all the people, right? All the persons, we will initialize the group and rank for each person. Now we have the find method, where what we will do, we will have this person, right? So we'll check if the person in the group, if not in the group, then we'll assign into the group, right? We will find this person's group, and then we will assign to this group, and this person index, right? We will assign. Otherwise, if it is in the group, we will return the group is already the person is already in the group, right? Then we have union method, where two persons we will merge, right? So we will find the group of individual person A and B. The group A and B is there. If both are in the same group, we will not do anything, we will return false. If it is in the different groups, we will merge it, but we will merge based on the rank. So we will merge the lower rank group into the higher rank, and for that this is the function we will do. So we'll check the group the rank of the group A and group B. If rank of group A is greater than rank of group B, we will say the group of B group of B will go into the will get assigned to group A. Otherwise the group A will assign into group B. Okay, otherwise there is another option. If these both cases are not there, means both are same, what we will do, group A will get assigned into group B, and then we can say we will do +1, we will assign group B in one more rank, right? And then we'll increment the rank, you can say. And then finally we have the merge is true now, so we'll return it. Okay, so this is the way, guys, like this type of tough questions you have to implement, right? And for that, definitely we have seen that there should be the more knowledge in the theory side, right? You should be aware with how UnionFind works, where it works, right? And then you will understand the logic, right? So let's continue to understand the time complexity and space complexity, right? So complexity, okay, so we have time complexity and space complexity. So if you are using UnionFind data structure, right? So if there is M as a, you can say, operations, M are operations, right? And either we are doing union or find. If there are M operations, we are doing for union or find, because this contains two things, that union and the other is doing find, right? Two things we have. So if there is M operations are there, right, either we are doing union or find, you got my point? Then the operations that we are doing on n elements, right? Then the total runtime will become what? O of M, right? And then we'll do dot proportional to n, like this, right? Where this part is the inverse Ackermann function. If you know the Ackermann function, right, I have already taught in my one-to-one classes and my lectures also. So this is a Ackermann function, right, where we provides the in the UnionFind data structure. And why we are doing that, you know that, right? If you don't do, let's assume that for now, and think that this is a inverse Ackermann function that we are using. Okay, but in our case the number of elements is equal to we are using what? UFDS, right? So the number of elements in UDF is equal to number of people, right? Correct, total number of people are like this only, right? So let's suppose we have n number of people, right? But we are also doing what? We are also doing sorting, right? To sort that, what we are doing, this will be the same, this will remain same, right? This will come for the UnionFind data structure, but apart from that we are doing sorting, right? So we have to add something here, or what we have to add, we have n number of peoples, right? And we are doing sorting, so we will write for the sorting m number of operations are there, and m log m is the sorting function in the Java, right? So total we will add like this, and now we will add this, so it will become O of n plus m log m, and then m proportional to n, right? Like this, because see, this is happening in the quick sort. We are doing quick sort because if arrays dot sort we are doing, this is called quick sort for the log, right? And for this we will get O of n time to initialize the array, and we are finding sometime group ID, right? We are doing merging, right? Those things we are doing, right? But for UnionFind and merge, we already knows that it will give this value, but for sorting of the logs, and we are iterating n number of elements, this will come like this one. Okay, similarly if we'll talk about the space complexity, guys, so what will happen, we have you can say n number of people we have, and m operations are there, right? Because union and finder we are doing, so total it will become O of n number of people is there and m operations are there, right? So you can take this one or m log m, right? Why we are testing? So O of n to keep track of the groups, right? This is to keep track of the group, we are storing the group and we are doing that, right? So if you want to keep track of the group, it will take O of n, but for there is m of number of operations, so we can take m, O of m, right? Otherwise if we are doing sorting of the spaces, then we can take O of log m, right? Because it is sorting, right? So either you write n plus m or n plus log n, like this you can say, log m, n plus log m. So this is for space complexity, guys, and this is for time complexity. Okay, I hope you will enjoy this video, and if you have any doubt, please ping me in the comment box. And if you want a one-to-one session, or if you want to join my online lecture or tuition, right, please ping me in the comment box, or you can directly contact me through the number, right? You can write this number 88.
Thank you guys. Thank you for watching this video. And if you really like this video, please subscribe this channel.
And I will connect with you. Thank you guys. Thank you for watching this video.
Thank you guys. Thank you for watching this video. And if you really like this video, please subscribe this channel.